Hello everyone, welcome and thank you for joining us today at SBG Systems. We're delighted to welcome you to our new webinar. We'll be taking a new deep dive into the new Ellipse. My name is Ali Halls and I'm the event manager at SBG Systems, and I'll be your moderator for the next 45 minutes. Now I'm delighted to introduce our speakers today. We have Kyoto Ben-McClough and Jeremy Colombo. Welcome Kyoto and welcome Jeremy. Thank you very much for joining us today. I will start by introducing Kyoto, who is going to be presenting the new Ellipse for us today. Kyoto is a product manager at SBG Systems, overseeing the product range dedicated to real-time navigation solution. She holds an engineering degree in space and aeronautical telecommunications and a master's in aerospace systems, navigations and telecoms. Before joining SBG Systems in 2022, Kyoto gained valuable experience at several multinational companies developing expertise in GNSS. And now let's meet Jeremy. Jeremy is the sales director in the Asia Pacific region at SBG Systems. With over a decade of experience in his field, Jeremy specializes in promoting and selling advanced inertial sensors positioning solutions across various market segments. He has a deep understanding of the unique challenges faced by our customers, helping them implement the best navigation solutions for their applications. Okay, so let's look at the agenda, what we're going to be looking at today. So first of all, Kyoto will do a small introduction, and then she'll present the new features and improvements in the latest Ellipse generation. Secondly, we will compare its performance to the previous models. How does the new Ellipse stack up against its predecessors? And finally, Jeremy will walk us through the key benefits these advancements can bring to your specific applications. And after that, we'll open up the floor to a live Q&A, so please get those questions ready. Okay, so now without further ado, let me pass over to Kyoto, who will kick off the webinar with a quick company presentation. Thank you, Kyoto.
Hello to everyone. So I'm very happy today to be here with you to introduce the Ellipse, one of the SBG Systems solution for real-time navigation. And for those who may not be familiar with us, let me start with a quick overview of the company. So SBG Systems is a French company founded in 2007. We specialize in designing and manufacturing high-performance inertial sensors and navigation systems. Today, we have more than 40,000 products deployed worldwide, from industrial machinery to unmanned vehicle to marine and so on. So our product line is designed to address both real-time orientation and navigation with IMUs, inertial sensors, and also for high-precision survey applications with solutions for surveyors. So it includes products from compact IMU to high and inertial navigation sensor, along with our powerful post-processing software Inertial. All of that is backed with a dedicated support team to assist customers from integration to deployment. And today we will more focus on the Ellipse series. It's our line of products of compact inertial sensors. So let's dive in. So our product, our Ellipse series, is our most compact and lightweight, yet highly performant inertial sensors. It ranges from simple AHRS to dual antenna GNSS-aided INS solutions. It's our field-proven solution, launched in 2040 with more than 30,000 products deployed worldwide in multiple applications, from UAV to ground robotics to marine vehicles to industrial machinery and more. What makes the Ellipse today more exciting is that the Ellipse series has recently benefited from a major update, which brings new capabilities and a lot of improvements while keeping the same hardware. so there is no need to rework the integration. So the new Ellipse and the new firmware was designed with a focus on 3 key pillars: robustness and reliability, with a new modern sensor fusion algorithm. So the new Ellipse offers more use cases and more stable and accurate performance with the smarter fallback strategies, so that now the Ellipse can handle difficult environments, for example, magnetic disturbances or GNSS-denied or highly vibrating environments. We have also new features to expand the range of the use cases the Ellipse can handle, and of course, its capabilities. And finally, we have the ease of use with the new Ellipse, with many improvements in configuration, process, and user experience. So now that you've got the big picture, let's go deeper. So in this presentation and in the next part, we will cover first the different variants of the product line. Then we will go deeper in the common features across all variants. And finally, the specific capabilities of the INS models. So I'll start with the product variant. Our Ellipse series is available in 4 variants with different level of capability depending on your needs. So we start with the Ellipse A, our AHRS that provides IMU, route pitch, and hidden based on the internal magnetometer. Then we have the Ellipse N, which combines inertial data with GNSS to provide, in addition to what the Ellipse A provides, position, velocity, time, and the dynamic hidden. Then we have the Ellipse D, which is our most complete product. It includes, in addition to what the Ellipse N includes, the dual antenna GNSS, which enables to have the true hidden even when in static. And finally, to complete our offer on the Ellipse series, we have the Ellipse E, which comes without embedded GNSS, but it supports external GNSS receiver. So the feature set I highlight here in dash points, like such as positioning and hidden, depends on the capabilities of the GNSS you connect. So the Ellipse E is our flexible option if you require a specific GNSS system. All those variants share some common features. So I'll start with that, and starting with the IMU. So all the variants from the Ellipse A to the full features Ellipse D share the same core IMU. This is really the heart of the system, a high performance MEMS-based IMU. It was entirely designed in-house with a tightly controlled manufacturing process to guarantee the integrity of the sensor. So before any SBG product launch, and especially here for the Ellipse, the IMU goes through an extensive qualification process where it is tested on a shaker table for vibration, in a acoustic chamber, on a chalk table, and in thermal chamber to make sure that the Ellipse is still reliable over the full operating temperature range. And on the top of that, every unit is subjected to a rigorous factory calibration performed across temperature from minus 40 to 85 degrees Celsius, and also across dynamics by rotating the system into in different axes. And this is something we do to all our products before delivery. And this is how we make sure that the Ellipse has a robust and consistent performance unit to unit. So no matter which Ellipse you use or you choose, you are always starting with the same solid and reliable foundation, which is the IMU. The second key feature shared across all Ellipse variants is the magnetic hidden. So every model includes a built-in 3-axis magnetometer. It is factory calibrated for first over temperature, and we also provide a dedicated magnetic calibration tool to adapt the sensor to the environment and the installation. So first, by design, we made sure that the Ellipse contains no magnetic or magnetically disruptive materials. So every material in the ellipse has been, and every component has been chosen to preserve the integrity of the magnetic field. But of course, we can't control what's around the ellipse once it is integrated. So that's why we have this powerful magnetic calibration algorithm. So the algorithm takes the raw biased magnetometer measurements affected by all like the surrounding magnetometer disturbances and output a clean, ready to use calibrated magnetic data. So all that is done by our advanced magnetic calibration algorithm that goes beyond what like just compensating the nearby magnetics or magnetic materials, or what we call the hard iron, or compensating for distortion from ferromagnetic materials, what we call soft iron. Our calibration algorithm also corrects for any magnetic coordinate frame misalignment to guarantee reliable hidden after calibration. And this last point, it's worth noting that SBG was the first to offer that level of correction to a sensor of this class. So beside the algorithm, we also focused heavily on user experience when designing the calibration process. So the calibration is available both in 2D and 3D, depending on your motion constraints. It is flexible, as you can do it either in real time or offline. We have offers through 3 different interfaces, either in GUI, if you are more familiar with that, or CLI, and it can also be embedded in your operating system. And the best part is that the calibration is valid over time, so meaning that you only need to do it once after the setup. And we all know, another thing to add, we all know that magnetometers can be affected by the surrounding environment. That's exactly what we've invested in, a smart integration into our sensor fusion algorithm to make the system immune to transient magnetic disturbances. One of the core features shared across all the Ellipse is our HRS algorithm that fuses the IMU and the built-in magnetometer. So our HRS algorithm is capable of delivering accurate roll, pitch, and yaw, no matter the dynamics. So it goes even beyond that. Our algorithm is optimized for motion. So we have dedicated motion profiles, easily configurable by the user. This leads to a faster conversions, better noise rejection. So whether you are in static or in motion, the Ellipse is able to sense accurately like your orientation. And on the top of that, we have several advanced optimizations for more like long-term robustness and to keep drifts under controls and stay immune to magnetic disturbances. We have quality checks, we have sensor bias estimation, and this is like how we guarantee that the sensor has a reliable orientation. We've also pushed the algorithm through its limits. We've run an extensive qualification test of the algorithm using vibration profiles inspired by the MIL-STD military standards. We've put the Ellipse on a shaker table, and it was subjected to random vibration and sine sweep vibration at different levels, up to the Ellipse specification, which is 8G RMS. And the result is that the Ellipse maintains a stable performance even in highly vibrated environments. So in short, it is an AHRS that you can trust in all environments. Another key features shared by all the Ellipse models is the HEAV filter for marine motion compensation. So it goes often unnoticed, but in marine application, sensing the vertical like movement is critical. So whether you are controlling, for example, a platform, or you want to compensate for motion or other, the heave filter is here. It is available in all the variants, and you might have noticed that I'm presenting here under the common features. That means that our heave filter works even in AHRS. You don't need GNSS to have a reliable heave estimation. Second, so our filter includes an automatic tuning based on sea state. We know that like wave frequency and behavior vary a lot depending on environment. So the algorithm adapts the estimation to actual sea conditions. And finally, on the heave, with always the user in mind, the Ellipse offer a flexible integration. You don't need to install the Ellipse at the center of rotation. You can place it wherever you want, and the Ellipse will still output heave, or any data, by the way, where you need it. Just a quick look at the performance of the heave. Just a quick look at the performance of the heave. With the new Ellipse firmware, the heave estimation has been significantly improved. So in AHRS mode also, where here I have the CDF of the errors, and what we can see here is that the 1 sigma error dropped from 4 centimeter to just 2.5 centimeter. So 2.5 centimeter for désolé. Je répète ce slide. So just a quick look at the performance. With the new Ellipse firmware, the heave estimation has been significantly improved in AHRS mode, not only in the INS. Here what we see is a graph of the cumulative, the CDF of the heave errors. And what we see is that the 1 sigma error dropped from 4 centimeter to just 2.5 centimeter in AHRS. That's like 50% improved, or 40%, sorry, for the AHRS. It's 40% improved in AHRS mode. And where like in the INS, it goes below the 2 centimeter. And this is like that kind of precision, from our most compact sensor, is something we're really proud of. And finally, the last common subject is about connectivity and drivers. So all Ellipse sensors offers various communication interfaces, like the standard serial communication RS-232 for our box version, or the UART for our OEM versions. We have also CAN and synchronization. And on the top of that, we also provide really ready-to-use protocols for different types of integrations. So whether you have an external GNSS receiver, a DVL, or any other heading, the data is already structured and the interfacing is easy to put in place. To make things even easier, we've developed official drivers for some popular platforms and ecosystems like ROS, ArduPilot, and Pixhook. And everything is available open source in our GitHub. Now that we've covered the common features, let's move to the INS specific ones, starting with the built-in GNSS receiver. So the built-in GNSS receiver in the Ellipse supports the full constellation tracking, GPS, GLONASS, Galileo, and Beidou. So you always have access to a strong set of satellites, even in challenging environments when you are in urban area or near some buildings. It is also dual frequency, which helps improve accuracy and better handle atmospheric errors on GNSS measurements, especially in this period of where the solar activity is at its highest. On the top of that, for high precision needs in real time, the Ellipse includes RTK or point perfect for centimeter level positioning. It also supports PPK for post processing, dual antenna if you need, reliable hidden even in static. And finally, we have OCNMA, which is already integrated for secure anti-spoofing protection on GNSS signals. And the second subject I want to cover is related to the Ellipse capabilities in jamming and spoofing areas. So we've built our approach around two key pillars. First, detection and alerting. So the Ellipse is equipped with smart mechanism to detect jamming and raise alerts when the GNSS signal is compromised. And as I said, it also supports OCNMA for spoofing mitigation. And second, we have the Ellipse is built to continue deliver position through circumvention. So when GNSS become unreliable or unavailable, the Ellipse doesn't stop. It automatically switches to the reckoning using its internal high performance IMU and magnetometers, along with external velocity aiding to continue delivering a navigation solution. And for the parts of the velocity aiding, we support a wide range of velocity sources, like DVL for subsea or air data for airborne platforms, but also a generic format input, for example, for your LIDAR velocity or your SLAM or other systems you already use in your application. So in short, even when GNSS is attacked, the Ellipse doesn't quit. It detects, it alerts, and adapts so that your mission can keep going. Now, let's look more technical on what really powers the Ellipse behind the scenes, our advanced sensor fusion algorithm. So this is like the same core engine, and I should mention it. It's the same engine we use in our highest grade INS. So you're getting high-end navigation performance in the Ellipse, which is like a smaller form factor. So our sensor fusion algorithm fuses data from multiple sources, from the IMU, the GNSS, the magnetometer, and external velocity aiding when available. And all of that is processed in real time, of course, to deliver precise position velocity and orientation outputs up to 1 kilohertz. So that ultra high output rate allows like for integration in control systems or fast moving applications where highest output is required. What sets our algorithm apart is like what we have here, the quality checks. So it's the smart decision making. We have some quality checks implemented in both the input and the output stage of the algorithm. So at the input, we verify the integrity of the raw sensor data. We filter out noise, glitches, or invalid values. And at the output, what sets our algorithm apart is that like smart decision making, that quality checks we have here. I highlighted in red. So this mechanism is implemented, as you see, in both the input and the output stage of the algorithm. So at the input, we make sure that the raw sensor data is valid. We filter out noise, glitches, and invalid values. And in the output, we monitor the consistency of the navigation results. And this real-time, I would say, self-awareness is a key for the reliability. And that's one of the things that allows the Ellipse to deliver clean and consistent navigation in even the most unpredictable environments. So to wrap up this first part, I will finish with the Ellipse specification in GNSS-denied. So thanks to the advanced sensor fusion, the Ellipse can continue to provide a dead reckoning position when GNSS is lost. Of course, like the performance depends on the vehicle dynamics and the type of aid available. This chart here gives you a quick overview. It shows the position error over time during GNSS outage. So here I choose 3 scenarios with 3 typical velocity, 50 km per hour for land, 20 km per hour for marine, and 120 km per hour for airborne. And as you can see, even without GNSS, the Ellipse maintains usable position accuracy. So the accuracy, of course, it depends, as I said, on the platform, but this makes it reliable when navigation continuity for a short period of time is critical. And with that, I will hand it over to my colleague, Jeremy. Over to you.
Thank you, Kautar. Thank you for your explanation. It's also a pleasure for me to be here today for the story. When I joined the company 11 years ago, we were releasing the first version of the Ellipse series. So it's really a pleasure here to be able to present our new generation. And it's nice to see all the improvement that we have done for those past years. So after having reviewed the technical side, I will try to explain a bit more example of application. We will not be limited to that, but this is to give you and your team an idea of what we are capable to do and to solve for you. So one of the first dynamic, as you have seen, the Ellipse is very versatile and can cover different type of dynamic. The one that is a market that we have for a long time now. It's anything on land based, so anything that is on Earth. It could be a pedestrian, a car, train, tramway, heavy machinery, truck, pretty much anything that moves there is something that the Ellipse is capable to handle. I picked up a few features. We are not limited to that, of course. This is just what we have heard and what we know that is pleasing our customer. The Ellipse is, of course, 11 years old now, but the new version can also enhance and unlock a new application in this type of market. What we have seen and what we know and what we heard from our customer is clearly our capabilities to provide optimized performance with dedicated motion profile. So Kautar explained already a little bit. We know that each vehicle has a different dynamic, and therefore we are here to tune and to refine those algorithms for those specific dynamic. Something also that we know and that is important for you when you are on land application, it's how to have a continuous solution when you have a GNSS difficulty. If you go under bridges, if you take a tunnel, if you are in a big urban canyon, and this is something thanks to the INS and the EK filter of the Ellipse that we are capable to provide you a trusted continuous solution in those environments for position, velocity, timing, and so on. Another thing important when you want to control your vehicles or your systems, particularly if you are in automation, in autonomization, so anything related to unmanned vehicles, is how can you trust the solution that we provide? How can you trust the data of the Ellipse? This is again something that we are very good at. It's providing real-time solution indicator that you can refer to in order to control and monitor your system properly. All right, let's dive to another type of application, something that we see more and more. And if the Ellipse at the beginning was designed more for industrial application, we have seen over the years, and even more with this new release, that we provide actually systems that are capable for military application, that are actually well suited for it. Why? Because we have robust and consistent behavior in harsh environment. This is typically why we calibrate it for -40 to 85 degrees. This is why we have extensive vibration tests and so on. Providing reliability and consistent behavior doesn't mean to lose in accuracy. We still, in a miniature form factor, integrate precise and accurate orientation. It's typically very interesting for the systems that are embedded in gimbal, for optics, for reconnaissance or surveillance. And this is something that you can find in the Ellipse units. Another thing that we have seen, and we had a case recently with some customer, when you use the MEMS technology, actually you have always a difficulty to have a transition with very long static dynamic. So you stay static for a while and then you start to move and move a lot. This could be typically the case for some systems that are in communications, for example, for some vehicles or antennas that are placed and then start to move. And with the Ellipse algorithms, we have designed it that we have a very smooth transition. We call it like smart switch. So it's a very smart switch from static to dynamic in order to have a seamless operation and solution. In addition to that, for our defense customer, of course, it's useful for other industry, but we've seen it for defense customer. Is how to improve a bit our solution, our robustness in PVT. We have something that is a bit more external, which will be the compatibility with dedicated antenna, like CRPA antennas that are capable to handle better jamming and spoofing, but also internally with our R&D, the design of, for example, of automatic heading fallback. As Kautar was explaining, we have the capacity to directly switch from a GNSS heading to a magnetometer heading in order to continue the operation even when your GNSS is targeted. All right. Another type of application that we have seen and we see more and more. This is also mainly due with our new release. Typically for UAV navigation, we are here more talking about industrial and military grade UAV. The PIXOX that we have, the PIXOX drivers that our team has developed provide you a seamless integration. So it gives you and your team the capability to quickly integrate and make it work with your autopilot. And with that, in addition, we have integrated in the new Ellipse air data input that provide more resilience and more dead reckoning capability, even in high velocity and in a dynamic such as a UAV. In addition to that, we have provided now an aiding for external magnetometers. It comes directly from the field when we know that some customers are integrated the Ellipse close to a lot of electronics equipment and therefore could perturbate the magnetometer and therefore adding an external magnetometer input located somewhere else away from those perturbations is something very interesting with the Ellipse series. In addition to that, also the MEMS could be very sensitive, and we know that we solved the challenge for our customer, but we have even improved it for higher demand, particularly when you have rotary rings, for example, that could be subjected to a lot of vibration. This is something that we can really solve and handle those challenges with a new Ellipse series. It's the Ellipse has different version. It's a compact. We have a compact AOM version, so we have designed it for volume application. Not only in the technical side, it's also designed in the industrial side. We here have the capabilities to produce large volumes in a short period of time. So from the supply chain to the R&D design and to the production, everything is suited for your needs of mass production when needed. Right, another application that we are pretty good at and we can be proud of, actually, it's the marine application. And this honestly really started when we were capable with the first version of Ellipse already to have an automatic eve adjustment. This is something key for vessel. We have developed advanced ship motion algorithms, and you have seen more recently we have even improved it. So now we have the capability in a very miniature sensors to provide ship motion and ship information dynamic that you used before, a product that is much bigger and more expensive as well. And now in a small form factor, something with low power consumption, so something really optimized for SWaP-C is available in the Ellipse series in AHRS or INS mode. Another thing is important for the marine, and we see that a lot, is our dual antenna GNSS. So is the Ellipse D, which is a miniature INS with dual antennas GNSS receiver. Why, again, in order to handle low dynamic that you can have, for example, when you are docked, when you are at the dock and you still need to have a solution. And then when you start moving, you again have a smart transition, a smart switch from low dynamic to high one. Those dual GNSS could also be interesting for anything that could be offshore for semi-static platform or structures that you want to monitor. All right, let's see a last type of application that we see more and more. It's really the subsea, everything underwater. Here we see two main approach from our customers. The one that say, okay, actually I need a reliable HRS, mainly because we will be working on a ROV, for example, remotely operated vehicles. In here, our job and what we have been doing is to provide accurate and mainly a stable HRS solution. Why stable? For two main reasons. The first one, because as mentioned, we have a lifetime calibration. So once it's integrated, you don't have to remove it from your vehicles or your platform. And another thing that is very interesting is the resilience to magnetic disturbance, as mentioned by Kauta. Typically, when you will be operating your ROV near metallic structures, cables, pipeline, and so on, we have the capacity to maintain the heading and the orientation properly for your mission. And the second part in the subsea, which will be related to INS, and this is something that we have improved a lot, and the new generation of Ellipse here will even be a step further in this application. It's to be able to provide you miniature underwater navigation capabilities, and this is something that we are very proud of, and we have a good expertise now, particularly thankfully to the capabilities to correctly and properly integrate the DVL. This is something that will provide heading source for the INS. And here we answer all the markets typically for AUV, miniature AUV integration, swarm of AUV for different type of application or market. All right. As you have seen, we have a lot of different type of application, a lot of different type of dynamic. I will take hours to cover all the example, and there is probably some that we don't know that we are capable of. Long story short, what we want to tell you, it's we are here really to be at your side with you and your mission and your team. What we provide is really a motion and navigation that you can trust in your operation during the entire life of your platform and your system. SBG Systems is not only the Ellipse series that we release, it's also more than 17 years of expertise that we have in miniature and high performance sensor, and that we bring, and as you can see that we improve years after years. We also, thanks to that, we want to thank our thousands of customers that trust us and that we have worldwide. Without them, we will not be able to continuously improve and to provide the latest technology on the market. As I mentioned, I've been here for more than 11 years. What I love with SBG System is you don't only buy a solution or products, you're really here to work with a team of passionate experts. We have a dedicated technical support, we have R&D, we have production. Everyone is here and has been here for a while to provide the latest technology and reliable solution to you. Long story short, we want to really provide you the solution that is adapted to your project. We have done a lot of development. We answer already a lot of challenges. If we don't answer them all, of course, we want to hear what's your next challenges, what is a difficulty for you in order to integrate any INS solution, and hopefully you will hear us talking about that development at our next webinar. Thank you for your time. I will now handle it back to Kauda to conclude.
Thank you, Jeremy. So now it's your turn to try it out. We have various offer of cables and development kits for the OEM version, a wide range of ready-to-use cables to ease your integration of the Ellipse and to make it quick. We also have, and to help you evaluate this time, we've tested and published real-world test reports across various environments. We have test reports in automotive, in airborne, in marine. We've conducted an extensive testing of our algorithms and of our units. So that way you can see exactly how the Ellipse performs in your application. In addition to that, we also have dedicated detailed documentation guides and tutorials on our support center. And of course, our support team is always here to help every step on the way. So I'll finish on that. Thank you for your attention. And now I will hand the mic back to Ellie for the Q&A session.
Thank you, Kyoto. Thank you, Jeremy. A really interesting presentation there, so thank you very much. So we're now going to move on to the Q&A. So we've had lots and lots of questions coming in. So I'm not sure if we're going to get the chance to go through all of them, but let's see how we get on. So let me have a look. And just a reminder, if you do have any questions, please feel free to put them in the chat box, the private chat box on the right-hand side. And if we don't get through all of them today, we'll get back to you another time, okay? So the first question. Okay, I have an Ellipse unit purchased in 2021. Can it benefit from the new firmware update? And is the firmware upgrade for the latest Ellipse generation free of charge? Kyoto, can you help me with that question, please?
Yes, I can take this question. So the new Ellipse firmware was designed first to be compatible with our products, with already existing products. It is compatible with all hardware version 3.0. So if you purchased your Ellipse in 2021, that means that you probably for sure you have a hardware v3, so it is compatible. Another way to confirm is to go through the SBG center. You are already familiar with that, I guess, since you have an Ellipse, and you can check by yourself the hardware version and make sure it is compatible. And the second part of the question, so yes, it is free of charge. It is available for everyone for download in our support center.
Great, good news. Thank you, Kieta. Okay, let's go on to the second question then. How can I choose the right Ellipse model from the product range? Perhaps Jeremy, can you help me with that question, please?
Yep, that one is for me. So for how to select the Ellipse, it's good questions. First of all, we hope that we can answer it for you, meaning like we would like you to connect with us, and we have a team of experts worldwide that are here to see what is your application, what are your constraints, do you need a box version on OEM, you have a specific interface, do you want GNSS or not? So there is a lot of questions that we need to answer in order to help you. So therefore, contacting SBG Systems will be, for me, the first and easy way to help. Otherwise, if your project is really confidential and you cannot exchange with us, we have on our support center, this mighty support center, we have a dedicated guide on how to select Ellipse, what are the version available, what are the compatibility with the cables and so on, that you can directly select by yourself.
Super, thank you, Jeremy. Okay, and let's go for another question for Kieta this time. Is it necessary to install the Ellipse at the boat's center of rotation for optimal performance?
Yes, I think I can take this one. So it's a good question, and actually no, not at all. You can place the product wherever you want. If you have any constraints of this kind, you can handle it for you. We have configurations that allows to like enter what we call the lever arms, which are like the distance between the IMU and GNSS or center of rotation. We already take care of that. And like to make things even easier, we've launched 1 month ago a free tool called Inertial lever arm. It's like a post-processing tool where you just need to upload your data after your mission, and the goal is to refine the lever arms for you. So that way you are sure you have the most accurate lever arms for your operation.
Super, thank you. Okay, let's go on to a question for Jeremy. What is the lead time for receiving an Ellipse after placing an order?
That will mainly depends on the model and the period of the year. Most of the time, we have some stocks. The Ellipse is something that we produce in a very large quantity. We have some standard model that we always have a stock here at the HQ to be able to ship. So if you use a standard model, that will be shipped right away on the purchase order. If there is a bit more difficulties at this time, usually it's about 2 weeks to get an Ellipse.
Okay, super. Okay, I think we have time for just one more question. Jeremy, if you don't mind taking this one, I think this is a good one for you. What makes the Ellipse different from other compact inertial sensors on the market?
Yes, indeed. So that one is a good one. It's complex to answer. Of course, it will depend on the competitor. It will depend on the market. But I still try to answer this generic question. What we have seen and what we have heard from our customer is the capabilities to provide something very accurate and reliable. SBG Systems, we are very conservative in our specifications, so we are sure to meet the specification. We see that most of the time the competition are a bit optimistic and can have some specification that actually they will not achieve. So we try and we know from the customer and the feedback that we provide something that they can trust during the entire life of the product. And I think this is one of the key strengths of SBG Systems.
And if I can add just one thing, so our product, as you may have seen during all this presentation, is qualified. We control our manufacturing process. We know exactly what we deliver to you. So our IMU, as we saw through the presentation, is qualified, calibrated before delivery. We tested our product. We are very confident of what our product can achieve.
Great, thank you. Thank you for everyone who submitted their questions, and thank you, Jem and Kota, for the detailed answers. I'm sorry we haven't had a chance to get through all your questions, but don't worry, we'll follow up with you after the session, so don't worry on that. We really hope you enjoyed the presentation today. It's certainly been very interesting. Yes, thank you for joining us, and we hope you enjoyed all about the new Ellipse and how it can support your navigation challenges. And do keep an eye on for our next webinars. We will have some other webinars later this year. So take care and see you next time. Thank you very much.
Bye.